The Y9DZ is a specialized airborne platform developed to conduct electronic intelligence (ELINT), electronic support measures (ESM), and related surveillance missions. It is derived from the Y9 tactical transport aircraft, which serves as a base airframe for a wide family of multi-role and special mission variants. The Y9DZ specifically reflects a focused adaptation of the original transport aircraft for the purpose of non-kinetic information gathering, signal tracking, and environmental monitoring in the electromagnetic domain. It is part of a broader evolution in airborne capabilities that prioritize information superiority through persistent and coordinated sensing across large operational areas. The aircraft uses a 4-engine, high-wing turboprop design, allowing for long-endurance flights, reliable operation in various weather conditions, and the carriage of a relatively heavy and bulky mission systems payload. The internal volume and stability of the airframe make it suitable for housing numerous sensor systems, onboard analysis consoles, signal processing equipment, and mission crew stations. The aircraft can remain airborne for extended durations, covering vast regions without needing to return to base frequently, which is critical in modern surveillance operations where continuous monitoring and data gathering are essential. Externally, the Y9DZ includes a range of noticeable modifications that distinguish it from standard transport aircraft. These include large, flush-mounted rectangular structures along the aft sides of the fuselage, often interpreted as housing wide-band passive electronic receivers. These antennas are likely optimized for collecting emissions from both civilian and military radio frequency sources, including radar signals, encrypted communications, and potentially other non-communications electronic signatures. These passive systems operate by receiving and recording the electromagnetic activity within the aircraft's wide area of observation without emitting any detectable signal themselves, allowing it to maintain a lower electronic profile while collecting high-value data. Further modifications on the airframe include additional antenna structures located along the dorsal fuselage and tail section. A prominently mounted oval-shaped antenna radome on top of the vertical stabilizer provides a higher vantage point for signal reception and is believed to support direction finding or high-frequency signal interception. Some units are also believed to have structures mounted underneath the forward fuselage that resemble synthetic aperture radar (SAR) arrays. If equipped, such a radar system would allow the aircraft to produce high-resolution images of the ground, independent of weather and light conditions. SAR is commonly used to detect changes in terrain, monitor fixed or mobile ground targets, and identify installations or vehicles otherwise obscured by foliage or camouflage. The aircraft operates with a mission crew composed of trained specialists who interpret collected signals, identify their sources, and record relevant characteristics such as signal type, frequency, pulse repetition, modulation, and direction. This information can be used to map out electronic order of battle information, essentially building a catalog of known emitters and their typical patterns of activity. This process supports long-term situational awareness and prepares operators to detect unusual or hostile behavior, such as the sudden activation of unfamiliar radar systems, the movement of mobile communication stations, or the presence of previously unregistered signal types. In addition to intelligence gathering, the Y9DZ may possess systems designed to support communication disruption or signal interference. While it is not confirmed in open assessments whether it can perform high-powered jamming, some of its variants or sister platforms are reported to engage in signal countermeasures. This could include localized jamming of specific frequencies used for communication, radar tracking, or satellite uplinks, possibly in support of larger operational plans. However, the extent of these capabilities on the Y9DZ specifically is not definitively known and remains speculative based on design similarities with other aircraft and known electronic warfare doctrines. The aircraft may also contribute to psychological operations or influence campaigns by broadcasting signals, such as emergency alerts, messages, or data packets into specific regions. This application would rely on directional communications equipment capable of projecting high-frequency signals into a designated area. The broadcast content may not necessarily be audible but could take the form of digital interference or targeted data packets designed to trigger a response in receiving systems or to interrupt ongoing communication channels. Internally, the Y9DZ is likely equipped with advanced computer systems to process large volumes of signal data in real time. This processing includes filtering background noise, isolating relevant transmissions, identifying signal parameters, and matching them against known emitter libraries. Modern systems use algorithm-based sorting to rapidly classify new or ambiguous signals. Artificial intelligence or machine learning techniques may be implemented to reduce operator burden and improve detection accuracy over time, especially in dense signal environments where traditional manual sorting would be too slow or incomplete. The cabin likely includes multiple workstations for operators, each focused on different mission segments such as radar monitoring, communications intercept, emitter geolocation, data archiving, or tactical coordination. These workstations would be connected to central data management systems capable of storing, cross-referencing, and transmitting findings to ground-based command structures or other airborne assets. Secure communication systems enable the aircraft to pass intelligence in real time, offering mission planners and commanders a dynamic picture of the signal environment, threat posture, or operational activity in an area of interest. In strategic operations, the Y9DZ functions as part of a broader surveillance and reconnaissance architecture. It complements other airborne platforms, unmanned systems, ground-based intercept stations, and space-based sensors, each contributing a layer of information. By integrating data across these domains, operators can build a richer picture of both the physical and electromagnetic activity in a region. The aircraft's large coverage area and endurance make it ideal for sustained missions during peacetime monitoring, military exercises, or periods of tension. It can remain outside of contested airspace while still observing relevant activity through signal collection. From an operational perspective, its deployment patterns likely include extended loiter times near sensitive air or maritime boundaries, circuiting over open regions of interest, or shadowing high-value surveillance corridors. These areas may include commercial and military traffic lanes, offshore installations, or regions where adversarial signal activity is suspected. The aircraft does not need to cross into restricted or heavily defended zones, as its primary function is passive collection. This use allows it to contribute valuable information without escalating tensions or drawing overt reactions. Although the Y9DZ is a relatively new and specialized aircraft, it fits within a long-established pattern of deploying airborne electronic intelligence platforms based on transport airframes. The design allows flexibility, expandability, and cost-effective reuse of existing production lines and maintenance infrastructure. As systems mature, upgrades are likely to be implemented through modular payload swaps, software updates, and improvements in onboard processing and networking. The future of the platform may involve tighter integration with other electronic warfare and ISR systems, improved signal classification tools using AI, and wider electromagnetic spectrum coverage. Additional upgrades may focus on resilience against jamming or signal deception, ensuring the aircraft can operate in contested electronic environments. Increased automation may also allow for reduced crew sizes and faster mission turnaround between deployments. While precise technical specifications remain limited in the public domain, the Y9DZ clearly represents a serious investment in airborne electronic surveillance. It fills a vital role in supporting long-term signal collection, strategic warning, and electronic situational awareness. As electronic and information domains become increasingly central to modern defense and security planning, platforms like the Y9DZ provide valuable capabilities that enable decision-makers to operate with better information, anticipate potential threats, and shape the environment through persistent and precise observation.